We begin by considering a result known as the n-term divergence test. The question we are trying to answer is there a relationship between the convergence of a sequence an and the convergence of the associated series to sum of an? We are going to begin by looking at some examples that hopefully give us some intuition of what's happening over here. So let's say we begin with an example. The sequence I'm going to consider is 1 plus 1 over n for n greater or equal than 1. We know that, well, we can see very easily that this sequence, as n approaches infinity, approaches 1. If we want to look at the series associated to the sequence, what we need to do is to look at the partial sums, Sn, sequence of partial sums, and see what happens with the limit as n approaches infinity. But we can very easily notice that since we are summing 1 each time we sum one term more, the partial sequence n is greater or equal than the natural number n. So this means that the partial sequence approaches infinity as n approaches infinity. So this means that the series associated to this sequence diverges. In fact, what the n-term divergence test says is that if we have a sequence and the limit is not 0, then the associated series cannot be convergent. So let me write this here more precisely. If the limit of the sequence an is not 0, this includes the case that an does not converge. So an divergent, or the limit as n approaches infinity of the sequence is some value L which is different from 0. So if we are in this case, then the series associated to a sequence A to n is not convergent. So we can use this test to, from the beginning, just by looking at the limit of the sequence, say that the associated series cannot converge. What we are saying here is that for a series to have a chance to converge, we need the associated sequence to have limit 0. But even if the associated sequence has limit 0, that's not enough. We are going to see now two examples when the sequence we start with has limit 0. In one case, the series is going to be convergent, and in the other case, the associated series is going to be divergent.